Welcome to Go Math Lesson 11.2. Today we are finding the measure of a right angle in degrees. In our lesson 11.1, we looked at that shading and we said that 1/4 of the circle is shaded in. We also discussed clockwise and counterclockwise. That's not really playing into what we're doing right now. But what we want to do today is take that knowledge that that's 1/4, and we want to see how many degrees of a circle that equals. Just to remind you, a whole circle is 360 degrees. So I'm trying to figure out what 1/4 of that would be. Well, the easiest way for me to do this is to change my denominator to be 360ths. Because if I think about it, in this picture, if I broke this up into 360 little parts, each one would be 1 degree. Okay, this is broken into fourths, and I'm talking about 1/4 of them. So if I could change this 1/4 and figure out how many 360ths is, that would tell me how many degrees I would use. So in order to do that, let's just remember to write an equivalent fraction, you multiply the numerator and denominator by the same thing. So to figure out what I multiply by, I can look at this problem and ask myself, what is 360 divided by 4? And some students are able to do that in their head with a basic fact, and some people have to go to the side and do it. If you think about with a basic fact, we have 4 and 36. 36 divided by 4 is 9, and then I add my 0. So I would have to multiply by 90 to get 360 here. And now what I do to the denominator, I do to the numerator, so times 90. That's our form of 1. So 1 times 90 is 90. Okay? So if 1 turn is 1 360th, that's 1 degree. Now if I have 90 over 360, that is 90 degrees. And we know by looking at this picture, a right angle has 90 degrees, so our math actually matches our knowledge of angles. If we take a look at the second problem on this page, this time we have more of our circle shaded in. So if we take a look, half of the circle is shaded in. So we know that this is half, and we went about it a couple ways. So some of the kids said, well, wait, I don't even have to think about that because it's a straight angle, and I know that a straight angle is 180 degrees. And I said, yes, but we need to prove that mathematically. So again, if we change it to a denominator of 360, then we will know exactly how many degrees it is. So 2 times 180 is 360. So 1 times 180 is 360. So we have 180 as our new numerator, and I know that the numerator over 360 tells me how many degrees because it's out of the whole circle of 360 degrees. So we just proved that that half circle making a straight angle is 180 degrees. So the problems that you'll be looking at look more like these on this second page. So if the fraction is already in 360ths, then the numerator just tells you how many degrees it is. That is 45 degrees out of the total 360 degrees you could have in a circle. Now this one, 1/12, is not set up yet in 360ths, so I have to change it to 360ths, and that will tell me how many degrees it is out of the circle. So I have 1/12 times something equals 360ths. Well, again, I can use my basic facts. 12 times what is 36? 12 times 3. So I have a 0, so it's 12 times 30. And what I do to the denominator, I do to the numerator. So 1 times 30 is 30. So that tells me that there are 30 degrees out of the 360 shown with this 1/12 fraction. Now number 4, they've gone all the way around, and they're asking how many degrees. Your answer is not going to be 1. It's asking how many degrees. So how many degrees is a full rotation? 360 degrees. Number 5, we have 1/10. I need to know how many 360ths that is. So again, I will set that up. 1/10 times something equals 360ths. 10 times 36 is 360. So 1 times 36 is 36. So that's 36 degrees of the circle. And if I were to put my protractor on there or think about what my protractor would look like, that really does make a whole lot of sense. Now on these bottom problems, we're just quickly classifying angles and triangles, and I'll just quickly review that for you. Okay, an acute angle is less than 90, an obtuse is greater than 90, but less than 180. A right angle is 90 degrees, and a straight angle is a straight line. So this first one here is obtuse. This is a right angle, perfect corner, perfect square. This is acute, and this is a straight angle. Now, if we're classifying triangles, we have a couple things that kind of take over. We first ask, does it have a right angle? And this one does. If it has a right angle, then it is a right triangle. It does not matter what the other two angles are. If I look at this triangle, every single angle is acute. They are all less than 90, so that makes this an acute triangle. Now this one has two acute angles, the 20 and the 40, but it has an obtuse angle, and so since it has the obtuse angle right there, then it is called an obtuse triangle. Just like the right triangle, if it has an obtuse angle, that name takes over the other two. The only way it'll be acute is if all of the angles are acute angles. I hope these strategies help.